approach to risk and compliance is very simple. Where it starts getting complex is when you start looking at how you need to feed the data in. You need to know all the different trading sources. You need to know all the different sources for market data.
You have to design around real time. It's the worst case.
If you don't have the right quality data, then how can you expect your results to have any level of quality whatsoever? What you also have on the risk side is you now have orders of magnitude of computation. If you multiply 500,000 trades with 10,000 different scenarios that each trade needs to be priced, you're talking 5 billion calculations. This is where you start talking about grid computing. From a very high level, compliance and risk is somewhat simple, but when you start looking at how you actually go about implementing this, it does require people. Building a risk system is somewhat equivalent to trying to save the Titanic from sinking using a teaspoon.
I think what's driving the new risk systems of today is that the expectation of performance is just so much higher than it had been in the past. In the most recent case, the need of our client was to improve performance of trade flow and allow for much faster credit risk. The client was losing business because they were unable to do trades fast enough and to do credit checks against those trades that they were performing. So we were able to improve their business by taking trades from seconds to milliseconds to achieve the highest amount of volume and guarantee the accuracy of the trades.
Why does a bank build a system? The new risk systems that are being built now are in direct response to the Fed and OSFI, which is the Canadian Regulatory Board.
IT managers have to understand a lot more about the management of the business, what the business is, than the managers of those businesses have to understand about IT. So we are an enabler of change.
There's a huge incentive for an organization, for an organization that has a capital markets division, for actually satisfying those regulatory requirements. If you have a better understanding of your risk, I think so far most organizations estimate and overestimate how much money they need to have in capital to be able to support their banking needs. Whereas here, if you get a much fine-tuned view of the world, then that does free up the cash. If you can get through, it's going to cost you 10 million to build this, then you could get a return on investment within 2-3 years based on the data or based on the observations you make as a result of the data you're producing. It's worth spending 2-3 months doing a proof of concept so that you don't spend 2 years trying to build something on fundamentally flawed architecture. Complicated systems require intelligent people to support them. It's like saying, if I want a Maserati sports car, racing car for NASCAR, that all I have to do is go and hire the local mechanic. If you don't have the right quality caliber of people to support it, then it's just going to crash and burn. By investing in these new systems that will satisfy the regulatory demands from the Fed, you can actually look at this more carefully. I've satisfied the regulatory demand. How can I now turn this into a cash positive system? If you do it the right way, that you can actually turn those costs into something that can actually generate revenue. The people costs are things that you need to invest in.